You can take just a few key taste and aroma compounds and completely recreate the characteristic flavor of a food. In my case, sourdough breadcrumb.
Hello, I'm Emily Schneider from the American Chemical Society, and welcome to this media briefing from ACS Fall 2023. A few years ago, amid lockdown boredom, it seemed like everyone was perfecting their sourdoughs. A simple fermented mixture of flour and water, the bread is powered by microbes that provide its one-of-a-kind tangy flavor. For over 100 years, sourdough bread has been synonymous with San Francisco, where today, scientists will report that they've identified and quantified 21 key chemical compounds that make this bread taste and smell so unique. They've also compared the levels of the compounds in different breads. We're joined today by Laura Eckrich from the Technical University of Munich. Thank you for joining us.
Thank you for inviting me.
How did you get the idea for this project?
Actually, it was my PhD supervisor, Professor Hofmann, who got this idea for the project. The Sensonomics approach was already used successfully for other foods, for example, for mushrooms, for hazelnuts, and for mint. So sourdough bread, with its amazing flavor, should be the next food.
Laura, what were you trying to find out with this research?
We wanted to identify the key taste and aroma compounds of sourdough breadcrumb. And we wanted to develop a new method that could quantify both, so the key tastings and the key odorants at once.
So what is so special about sourdough bread?
So actually, the bread making process is very important for the flavor. Like you can see here, the rye flour and the water are just the basic ingredients. And very important are the parameters of every sourdough bread making step. So there are special temperature and time parameters for every step. And in this process, these special flavor compounds are produced. In the last step, the sourdough is baked. And like you can see, all the sourdough microbiome consists of the microbiome that is included in the ingredients. So that means one part comes from the flour, one of the water, and one of the environment. That means, for example, for San Francisco sourdough, it's very special because of the microbiome that is already in the air there.
And why is this an important thing to know?
This could be important for bakers who need to control the quality of their breads. For example, preventing them from being too sour, or if the raw material changes, then they can investigate with this method I developed, so what is the reason for this?
And then how did you investigate this?
So we investigated with the so-called Sensonomics approach. I will show you on this slide that we started with the breadcrumb. And at first we isolated the basic taste compounds and quantified them and identified these compounds. Afterwards, we calculated the so-called dot factors. They are calculated by the concentration of the tastings and the taste threshold of the specific taste compounds. Afterwards, we reconstruct this taste with the taste model. You can see at the slide that we use pure compounds in their natural concentrations, how they occur in the sourdough breadcrumb. Then we compare the taste profiles, and afterwards we try to reduce the number of taste compounds that we found. So we carried out omission tests, and they are in our jargon named as triangle tests. So we try to omit one single compound. In this case, at the slide, you see this brown compound is omitted, And then we compare the complete model with the incomplete model in the triangle test. And if the panelists can taste a difference, so a significant difference, then this compound is a key taste compound.
And what did you find out?
So we find out that just 10 key tastings and 11 key odorants are enough to completely recreate the flavor of sourdough breadcrumb. And that we could also develop a method that can analyze both the key tastings and the key odorant just in one single LC-MS run.
And how can people use this knowledge in their everyday lives?
The people can just enjoy the flavor of the sourdough breads, and the bakeries can, like I already said, control the quality of the breads using this method.
What's the advantage of this method over what's already used?
It is the first time that we are able to quantify both together, so the aroma and the taste compounds of sourdough breadcrumb. And compared to other methods, it's way faster and it's still sensitive and precise.
And what's the next step in this research?
So the next step is to apply this method. We already carried this out. We bought not just sourdough breads, but also yeast breads, and we try to compare them and also analyze not just the breadcrumb, but also the bread crust. And we could see a lot of differences in the aroma and taste compounds.
Well, thank you so much, Laura, for sharing your research with us.
Thank you for having me.
Be sure to check out our other media briefings for ACS Fall 2023, which will be posted throughout the meeting at www.acs.org/ACS Fall 2023 briefings.